Okay. I'm not going to be super picky if you guys don't want to write down every single item that's on here, but obviously if I take the time to do it, you probably should write it down. So variables, just like in any other class, the variables we're going to be working with mostly, X will be used like up until the first exam, just because that exam includes like solve this equation and they'll use the X variable. After that, pretty much the variables you're going to use will be T for time, R for rate. They use A. I can't remember what it stands for, but they use it. And then P for principal, capital I for interest. So you'll get them as we go. A term is a number, a variable, or the product or quotient of a number and variable. They give you lovely examples here. Okay. And I post everything up on Canvas, YouTube/Canvas, the same day. So if you ever miss a class, you'll be able to go in and just watch the video. You can obviously pause to do notes. An expression can be a single term, but it is often the sum or difference of two or more terms. An expression does not contain an equal sign. So you can have multiplication, division, addition, subtraction. You can have decimals, fractions, whatever you can think of. But as soon as you see an equal sign, it is no longer an expression. It becomes an equation. And that, of course, is the next term. No pun intended. Okay. An equation is two or more expressions that are equal to one another. Each equation has a left side and a right side. What they're showing you here is a simple equation. It's what we consider a one-step equation. If you have trouble with one-step equations, you definitely want to come see me during office hours. Your exam basically has maybe one-step equation, and then the rest are all multi-step. Okay. Solutions are obviously answers to equations. And then you always want to check. In order to check, you have to get your solution and then plug it back in. If you don't get a true statement, then you've messed up somewhere. Okay. All right. Your basic rules for solving an equation. I typically don't teach equations with words. I just do them. So let me see if there you go. All right, so if you need the wordy parts, let me know, but math is typically just a bunch of practice. So you have to undo the operation in order to figure it out. So if it's x minus 9 equals 15, obviously the opposite of minus is going to be plus. So you cancel it out on the left side. You do the addition on the right side, x equals 24. Well, how do we know that's right? 24 minus 9 will give us back to 15, and that is a true statement. So okay. And they just showed you what I already said. All right. Okay, this is just a second example. I don't really think we need it there. All right, so example 3 is now undoing multiplication. Opposite of multiplication, of course, is division. And again, once you figure it out, how do you know it's right? Well, 5 times 12 will give you 60. Okay. If you've taken Math 105, this should be old hat to you. Same with Math 90. Okay. This one, a little bit different. We'll go over it. You want to multiply by the reciprocal. Okay. And if you don't remember what that is, that's just where you take the fraction and you flip it. Okay. What you can notice here is 3 goes into 9 3 times. So 3 times 4 gives us 12. How do you know if it's right? Well, 3/4 of 12 will give you the 9. Right. I do apologize. I'm typically a lot more lively in class when I can run around and look like a fool, but I can't really run around here. I'm a little bit tethered and I would go off camera. All right. The multi-step equation, that's going to be something you want to pay attention to a little bit more because that will be on the test. I think there's 2, maybe. I didn't give a lot of point value to them because I feel like it's just information that you should have coming into this class already. So I'm not going to ding you if you don't remember it. I do have reviews for you. So if you do work ahead and you don't see the review available yet, just email me and I'll send it to you. Again, same thing as with a simple equation. Once you get your solution, you plug it back in and you check to see if it's right. 2 times 6 will give you 12. 12 plus 5, 17. 17 equals 17 is a true statement. So we know that m equals 6 is correct and the slide is not lying to us. All right. I don't think we need to do that. Okay. Combining like terms in an equation. When you have an equation that needs to be simplified before you can keep working with it, you have to combine those like terms. The example they're giving here, I mean, if you really need this step where you pull out the 5 plus the 2 and then shove the variable back in, you can do it. I'm not going to tell you you don't. I'm not going to tell you either way. You don't need or not need that step if you need it. That makes sense. Okay, so if you can do it in your head, great. If you need to write it out, okay. I'm not going to tell you don't have to. All right. What you do need to pay attention to is that y and x are not the same thing. Okay. The only time you get to say that they are the same thing is if they actually are, in which case, why would you use 2 different variables and not just the same one? Right? Okay. You definitely want to pay attention to this problem. If you notice they have the 3 y's here, you'll see something very similar on your test, but a little bit different. So you'll want to be able to do that kind of thing. And then once you combine it, you just finish it out with the division. I can tell you that for my 105, I definitely give bonus if you show me that you're checking your work each time. So if you want to keep that in the back of your mind, I especially do it when not everyone is doing it. So if everyone in the class checks their work, great. If only like 2 or 3 people are checking their work, then congratulations, you're more than likely going to be getting the bonus for that.
I have a quick question.
Sure.
For checking your work, like if we're writing stuff down on a piece of paper to do our work, how are we going to show you that we are like checking it?
That's an excellent question. Because my quizzes and my exams are on paper, you have to email me. Like you can use your phone, you can use a scanner. I use a scanner that's on my phone. But however you want to get it to me, some people are super lucky and they have these awesome little tablets and they do something called the Google Paper. I don't know, it's super neat. It's only like $7.99, so might totally be worth it. But if you want to be a little bit more environmentally friendly, you can do your work on there and then just make it a PDF and send it to me. So yes.
Do you need to print out the exams and stuff then?
No, I don't care how you do it. As long as it's organized, you don't have to write the question out. You can just do question, 1, 2, whatever. Make sure your work is organized. Basically, if I can look at it and see what the question was and that, yes, that's your correct answer, hopefully. And then I'm not sitting here going, gee, does this one go here or does it go here? Now, I won't lie to you. Like I said, I'm pretty nice. I have played Find the Magical Puzzle Pieces of exams before. It's just not really what I prefer to do. And I do often let them know in the feedback, hey, your exam was rather difficult for me to grade. So if you don't like the grade, I probably just missed something. Let me know where it's at. I should also let you all know that I give ridiculous individual feedback. So if you make a mistake, you're definitely going to know because I literally go through and say, question 1, this was kind of the issue. Question 2. The only thing I don't really pull up is like, if you got it right, I'm not going to type in question 3, you got it right. I don't do that. Trust me, once you see your first feedback, you'll realize how much work I put in and you'll understand why I don't give myself even more work. Okay, distributed property. Clearly that's when you have a term outside and you're multiplying it to everything inside. So then when you're done, it should be in both pieces. Okay, if anyone is more of a wordsmith than a number person, feel free, you can write these steps down. I will give you time to write them down if you prefer. Basically, when we solve an equation, we want to make sure that we remove all parentheses on both sides of the equation by using distributive property. Second step we want to do is combine all like terms on both sides of the equation separately. And then you want to start playing around with manipulating the equation. If you would like to use all of the words that they're using to say that, feel free. Okay. And then in the future, I know right now we're just going over kind of some basic stuff. I do tend to teach a little bit fast. That's both remote and in person, but it just seems to work out that in person, students can kind of keep up a little bit more. If for some reason you need me to slow down, please just ask, but also be aware that you can rewatch the video and then pause, just like you would with any other YouTube video. I do it all the time. Okay. Does anyone need that last step? It's basically just finishing it out. Okay, cool. All right, I don't think we need to go over this super long example, but if you would like me to, we can. You can see there that in the first line you have to do the distribution, and then they're starting to combine the like terms. And once they get down to just an expression on each side that's rather simple, then they divide r equals 4. Of course, if you wanted to, you would throw it back in to do the check. All right. Any questions on 4.1? Congratulations, you guys are the quickest math class I've ever had. You've gone from chapters 1 to 4 in one day. Okay, I'm normally pretty quick, but I am never that quick, so that's pretty cool. Go ahead and check out 4.2 before we sign off, if it will load. Any questions for me on that first section? Okay. If for some reason you guys find that the PowerPoints are just kind of not helpful to you, just let me know. I am more of a practitioner of math than I am a reader of math. So if you really aren't learning from the PowerPoints, please let me know, because I have been known to basically chuck a whole modality out the window if students aren't learning from it. Okay, so our objectives right now are going to be translating phrases into mathematical expressions, writing equations from given information, and solving application problems. I will let you know that once we go into chapter 5, pretty much the majority of our questions in this course will be applied. Okay, you're going to be given a situation and you have to then apply the knowledge. You'll have to know when to use what table. Now, Pearson's kind of nice because they basically give you the tables that they want you to use for each problem. But when it comes to the quizzes and the exams, you'll have to know which problem uses what table. Now, I'll give you the tables. You can use those. You can print them all out right now if you really wanted to. But you're going to have to know how to use them. Okay. Maybe if I'm feeling really nice, I might tell you which table I used, especially if it's a problem that's going to make me pull my hair out. I might be nice and do that. Okay. All right. So hopefully we can get to an example soon. All right. We'll go with this one. Why not? So 5 plus a number, if that's literally what you're given, then you just know that you need the number 5 plus is an addition sign and X. Now, the only thing I will tell you here that I would prefer to see that they did not show is something called a let statement. I don't know if you guys have heard of that before. It's fairly easy. You basically do something like this. Let X equal number. Okay, it can be that easy. All right. I should also let you guys know that I'm a huge proponent of actually practicing the math. So with such a small class, definitely don't be surprised if I tell you guys to use the mouse and do it. And then you guys get to appreciate a little bit how hard it is to actually write on this thing. It's not as easy as it looks. Okay. All right. So I don't think we need to go over that. I don't know why they just keep showing us more of the same thing. Okay. So when it says less than, you're going to use subtraction. Okay. I promise after chapter 4, it's not nearly as much of a review. Product, of course, is our word for multiplication. And then this is an interesting one for letter C here. 2/3 of a number. Of also means multiplication, but it's multiplication of a fraction. Okay. Quotient is obviously going to be division. And then if you have two numbers being multiplied by the same thing, then you have to realize that you're going to use parentheses. All right. I know it seems rather reviewing right now, and chapter 4 is under the prereq information for a reason. But I'm telling you, if you don't brush up on this stuff, not so much for chapter 5, but man, some of the other chapters, you really are like, man, I never thought just adding and subtracting numbers could be so difficult. especially whenever you do everything and you think you're following every step right, and then you get it wrong because it's off by 3 cents because you made one small mistake. Yeah. Okay. You guys just wait till you catch up to where I'm at, and then you pop on the Zoom and go, okay, I'm getting a little bit cranky with this problem, and I'll go, I understand completely. Okay. Let's see. Do we need this information? I guess you can pause it later if you want to look at it. So basically they're saying translate the product of 5 and a number decreased by 8 is 100 into an equation. Okay, so the product of 5, a number, decreased by 8, the result is 100. Okay, so there's your equation. You got it from those words up top, and now you just have to solve it. Okay. And the answer, in case anyone is interested there, was 28. How can you check that? Shove the 28 back in. All right. That is another one that I think you guys can do. So, okay. If you're, again, more of a wordy type person than a just solving examples kind of person like I am, application problems, these are the steps. Read the problem carefully. I'll repeat that part. Read the problem carefully. Trust me, the majority of the mistakes are because you're like, oh, I know how to do this, and you spent 0.25 seconds trying to read it and you read something wrong, and then you got the problem wrong. All right, a sketch may help. That's going to be more for other classes. I mean, if you guys really want to draw out a bank deposit box, you can, but I don't really think it's going to help you in this situation. I mean, if you guys want to include sketches on your exams and they're related, go for it. I have been known to give bonus points for it, but again, I don't think it's going to be too much in this course. I've yet to come across anything where I've drawn out a sketch for it. Identify the unknown and choose a variable to represent it. That's going to be your let statement. Okay, so that will be a little bit important. Translate the problem into an equation, solve the equation, answer the questions asked in the original problem. That's important. Definitely don't just stop at solving the equation and think you might be done, because the questions might actually have you doing stuff with that solution. Check your solution using the original words in the word problem and be sure your answer is reasonable. That one's a little bit super good for you guys to remember for this class. Obviously, we can have dollars and cents. You clearly don't have cents, anything past cents. So if you need to round, then make sure you round to 2 decimal places. Don't be like me and sometimes jump a decimal place, and then that's why I get the problem wrong, because I rounded wrong because I apparently just saw all the numbers together. So take your time. Also realize that you can't have half of a $10 bill. That would be illegal, and you just would want to use it as a $5 bill. So kind of make sure those things are being figured out in your head before you tell me that you have 25.25 $10 bills. Okay. All right. I guess we can go over that one if you really want to. Sure, I guess. Why not? We'll go over it. So Ben James is studying monthly demand for Chevy Impalas in 2 different regions of the country. He has 14,200 new Impalas to ship to the 2 regions. He decides to ship 3,350 more to the Southeast region than to the Mid-Atlantic coast. Find the number to be shipped to the Mid-Atlantic coast region. Okay, so In theory, you could probably just figure that out in your head, but let's go through and do it the way we should do it. We're going to let M equal the number of Impalas to be shipped to the mid-Atlantic coast region. Then M plus 3350 will be the number shipped to the southeast region. The sum of the two shipments is going to be your 14,200. This is going to be a perfect example of if you have a point something, you're obviously not going to send just a tire to the mid-Atlantic. Okay, so you will round up. But they were nice to you. So your answer is 5,425 are being sent to the mid-Atlantic, but you wouldn't be finished there because then you have to figure out how many are getting shipped to the southeast. So you do that subtraction. Okay, how do you make sure if the answer's kind of working out there? Well, like I said, we don't have a tire or a steering wheel being shipped by itself. So you know that you figured that one out correctly. All right. I don't know if we need to go over that one. Has anyone taken 105? Okay. So do you guys remember the ticket question? Like the terrible ticket question? It was in Math 90 as well. It's like, you know, if there's a theater with 5,500 seats and you have tickets selling at $6 and tickets selling at $8, you know, how many, and you have a profit of blank, that question is on your test, but I also have it on the review. So make sure that you guys pay attention to that question. I don't know if it's going to come up in the PowerPoints or not. Okay. We are going to talk about some business formulas. And I promise I don't go this fast when the material is new. So chapter 5 will not be getting done this quickly. It's just because this stuff, chapter 4 stuff, should be a slight review to you guys. Okay, so there are a ton of formulas out there. Many formulas. Formulas for physics, chemistry, calculus, trig, very many large number formulas. Unfortunately, there's also a lot of formulas that we will be using in this class. The first one being your I equals PRT, which is your interest equals your principal times your rate times your time. This problem can be arranged in a few different ways depending upon what it is that you are looking for. Okay. So if we obviously wanted to find interest, well, that's pretty nice as long as they give us the principal, rate, and time. And you're just going to multiply them all together. Okay, fairly simple there. But what if I wanted to know what the principal was and I gave you the interest, the rate, and the time? What would you do? Are those letters as heavy as Stonehenge and we have to keep them there the way they are for life? Oh, okay.
You just have to switch the P and I.
Yeah. So yeah, what's going to happen is we'll have to have a little bit different of a scenario going on. So if we want to find principal, but we know the other three, and I will tell you that you must know the other three in order to find one, then yes, we are going to move the principal over, but right now I would get rid of what's with the principal. So, like you said,
Oh,
which no one else got to know because it was through a chat and probably no one else looked. Okay, divide, right?
Yeah, right. Okay, yes, that was right.
Okay, so principal would equal interest divided by rate times time. So here's something I would highly suggest for anyone. If you have some note cards, or even if you don't want to get note cards and you want to do it in your notebook, I would take this interest formula and I would make a little table. So if you want to know interest, then you know it's P times R times T. Then we want to look at principal, then you would have principal equals interest divided by rate times time. So if you're interested in rate, then you know it would be rate is equal to interest divided by principal times time. And then time is going to be equal to interest divided by principal times rate. Okay. And if you do that ahead of time, then you don't have to worry about, well, oh no, I have to find rate, but the only formula I know is I equals PRT. Okay. So you can choose to do it ahead. You can choose to do it after, or in the moment, however you want to do it. But I would just go ahead and do it now. Right? Okay. So again, they're giving you the original equation. They gave you principal, they gave you the rate, they gave you the time. Just plug it in. So your interest is going to be 12,060. So that's where interest is being nice to you. You've probably all heard of interest another way as well, and it's not so nice. When is interest not so nice? What situations can you think of?
When I'm in debt.
Yeah. So, car loans, home loans, student loans, all of those have the interest on it that we don't like. So there's a credit interest where you actually get credit towards you, and that's a good thing. And then there's interest where we have to pay it back, and that's not such a great thing. Okay, so this one, they went ahead and they actually wanted you to find principal. They chose to go from the original and work backwards. But if you already rewrote the formula, you could just plug it right in. Okay. All right. This one's a little bit different because this is talking about maturity. So they're giving you M equals P times 1 plus RT. Again, they gave you what you needed. You just plug it in, and then you kind of rearrange to figure out your rate. Rates will always be in percentages. So if you find R, then you have to know that you have to multiply it by 100 and give the percentage. If you stopped here at 0.09, I'm not a program. I'm not going to look at that and realize that you just forgot to do the percentage. I'm going to know what you forgot to do and probably only take off half a point, to be honest. But truly the answer should be in percentage, and I would let you know that. Pearson will tell you that you got the whole problem wrong, and they won't tell you why. They'll give you like a general hint. they'll say, hey, you need to remember to do blah, 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 blah. And you'll read that and go, that's exactly what I did. So always know how Pearson wants to have the solution. That's half the battle. Okay. This is another good example where if you're giving this formula, you might want to try and just have written out for yourself already in a table. How do you find P? How do you find R? How do you find T? They're going through and helping you with this one to give you what T is. So it's probably a good start for you. Okay. And again, you just throw everything in. That's all they wanted for that question. For this one, you needed to rearrange it. And again, solve for T. All right, so yeah, fairly easy. Those are basically most of the equation problems that'll be on your test. Finding gross sales, it's N times P. So if you sold 481 fishing lures or 481 units, 481 anything, you multiply it by the price of one unit, and then you will get the total sales. I don't really ever understand why they use the word gross and not just total. I mean, to me, I think a lot of money is nice and the opposite of gross, but they always use gross, so guess gross is what it will be. Okay. That's just another throwing it in. It is an example of a markup, which is nice to kind of look at. You will have to do markups and marked downs, but not until chapter 8. So, okay. Exponents are used to show repeated multiplication of a quantity called the base. Okay, so after significant research, Ben James believes that the number of Chevy vehicles that can be sold in one state can be forecasted with the following. So sales equals $40 plus 16.2 times A squared. Both advertising and sales are in millions of dollars. Each sale for July's, if advertising is 1.4 million, so you substitute in the 1.4. And then you get the forecasted sales to be right there. All right. Obviously, what did you have to remember to do from this answer to this answer?
Change it to dollars.
Yeah, so not only did we change it to dollars, but we had to remember that they were in millions of dollars. So that's literally all they did. Now, if you would have gotten to here and you told me that the answer was $71.75, I wouldn't massively ding you, but I'm hoping that you would be able to look at that and go back and read the problem and go, wait a minute. If they're using $1.4 million worth of ads, I don't think $71.75 makes sense for how much they're going to be selling. Okay, so that's what they talk about when they say make sure that something is making sense as an answer. All right. Any questions on what we've covered so far in chapter 4? I don't know if there is a chapter 4.4. Of course there is. We'll get there. I think that's the end of it. Oh, good, it is. Okay. Ratios and proportions. All right, we're just going to go with the examples so that if you guys have questions, I can answer those for you. All right, the ratio of 5 hours to 3 hours. This stuff is not hard. If you are told to find a ratio, whatever comes before the 2 goes either in front of the double colon, you know, the 2 colon dots, or it goes on top of the fraction. Most likely you want it to be in fraction form for what we're doing. Now, if you would have written down 5:3, I would have still given it to you as a correct ratio. Okay, find the ratio of 5 hours to 3 days. This one's a little bit different. If you look above, these were both hours, okay? The units must be the same. You cannot tell me 5 hours to 3 days because that is not something that I'm going to care about. What I would care about are hours to hours. So you have to take 3 days, multiply by 24 and get your 72 hours. Now, some students might say, well, why can't I just change my hours to days? You could if these hours were more than 1 day. Right now, with it being a 5, you would have to tell me that it would be 5/24 day. And that makes it a fraction. It makes it ugly, and you don't want to go there. So stick with something that will keep it as nice as possible. Also, make sure that when you give a ratio that you give it in lowest terms. Okay, so if this would have been 75 hours instead of 72 hours, you would have wanted to make it the lower fraction. Make sense? Okay. Here you can see that they're showing you that you have to reduce into lowest terms. Oh, I love Burger King, and I don't get it right now because I have to watch everything. So let's make me really hungry, shall we? All right, Burger King sold the following items in a 1 hour period last Friday afternoon. Okay. Apparently they were on a college campus because let me tell you, that's a lot. So 70 bacon cheeseburgers, 15 plain hamburgers, 30 salad combos, 45 chicken sandwiches, and 40 fish sandwiches on a Friday. It had to have been during Lent or something. Okay, so they then want you to write ratios for each item sold. They would have told you that. Okay, so bacon cheeseburgers to fish sandwiches, 70/40. Well, we cross out the zeros, 7/4. Okay, salad combos to chicken sandwiches, 30/45. 15 goes into both, so 2/3. All right, we understand. Solid. A proportion says that 2 ratios are equal. Okay, so 3/4 is equal to 15/20. Well, 5 goes into both, so 3/4. We can prove that. A/B equals C/D is true if the cross products A dot D equals BC. Okay, so basically if A times D equals BC, then it's a ratio. If it is false, the proportions are not true. Okay, that's how you work that. So when we solve, I'll leave that up for a second if anyone wants to write it down. You will see on my exam 1 review, I show you guys a couple of different methods of how to solve something. Proportions are going to be the easiest way for you to solve some of these problems. And then things get confusing and I don't understand why they don't work, but you can use the base thing that we're going to do next week. Okay. Okay, for numbers and or variables are used in a proportion. If any three of the values are known, the fourth can be found. The two methods to solve proportions are multiply both sides by the product of the two denominators or use the method of cross products. That's basically the same thing. So 3/5 equals x over 40. I like doing it where you take 3 times 40 and you get 120, and then 5x, divide each side by 5, x equals 24. Okay, that's how I do it. You can also do it from a word problem. A food wholesaler charges the restaurant chain $83 for 3 crates. How much should it charge for 5 crates produced? Well, remember the crates have to go together. So 3/5 equals 83 over x. Why is the x on the bottom? Why do you guys think the x is on the bottom? Because what do we know? We know 3 crates cost $83, but we don't know. Excellent. Because that's the amount we're trying to find. So since the 5, we don't know the cost, those have to match up. Does that make sense? Okay, good. All right, and then we cross multiply and you find that 5 crates cost $138.33. We're allowed to have that. Why? Because you know that there are dollars and cents. Okay. I say that's pretty much solid information. If you guys feel like you need more information than that, then I would suggest going through the rest of those PowerPoints. I'm not going to